Welcome back to Module 7 of Engineering Vibrations 1. This is an introduction to single degree of freedom systems. Today's learning outcome is to develop the third of the three system elements. This time we're going to look at the damper, and this is what's used to model vibratory systems. So again, we are at this point in our forest, if you will. We're taking some actual system and we're physically modeling it with masses, springs, and dampers. So today we're going to talk about the dampers. So we're going to work with linear dampers, and this is how we're going to portray it. A damping takes energy from a system, and there's a couple of ways of doing that. The most common way in vibratory systems is viscous damping, and that's what we're going to use. Viscous damping, the velocity is proportional to the force in a viscous damper. And I'll show you some examples here in a second. C is the damping constant, and here are the units in both the International System of Units and the English or Imperial System, Newton seconds per meter or pound seconds squared per foot. So as I said, the force is proportional to velocity in this viscous damper. So it's proportional by the damping constant C. Now there are other ways of getting damping. One is dry friction damping. You've had dry friction in statics courses and other courses, mechanics of materials. That's where the force is proportional to the coefficient of friction times the normal force. But we're going to look exclusively at viscous damping in this course. And so the relationship is F equals Cx dot for a linear damper, translational motion. And we can also have rotational or torsional a torsional damper, and there the moment applied or the torque applied to the torsional damper is proportional to the angular velocity by the damping constant, the torsional damping constant, which I've indicated as C sub T. So some examples that I'd like to look at are, first of all, that same vehicle that we looked at in the beginning of the course for the introduction, which is this vehicle with a suspension system that's bouncing around. And next, I want to show you a demo of a bicycle that has been installed with a damper at the seat and the frame. And so you can see how that damper is going to take energy away from the system and dampen out the motion. The next video shows some lab equipment that we use in our undergraduate labs to teach vibratory systems with masses, springs, and dampers. And you'll see in this overall picture that the damper is at the bottom. And then I want to show you a close-up of the damper where you can see there is viscous fluid moving through baffles as the vibratory system goes up and down and removing energy from the system. And finally, I'd like to give you one more example. Here's a bicycle pump. And as I go up and down, you can hear that damping action. The force is proportional to the velocity, and you can see that it takes out energy as I go along, this damper. And so that concludes today's module. We've developed the third of the three system elements that we're using in the course to model vibratory systems. This module focused on the damper, and we'll see you next time.